Okay, let's look at another example, slightly advanced than the price elasticity model we looked at. Yeah. Uh, we're going to look at Monte Carlo simulation of this model using native Excel functions, and then we will look at risk. And when you're at risk, we will take it a little further than what we did with the price elasticity model. Okay, so here we have some. First, let's start with the deterministic model. Okay, so we have a particular product, book or something, um, where the cost of the product is $7.50, and unit price is $10 that we're going to sell. And if you're not able to sell, and if you have to return, so we get $2.50 back. That's our unit refund. Okay, so that's let's make it currency, and I'm going to use some color coding here. So this is deterministic input. Now demand. Okay, let's take the average out here. Okay, so demand, it's an uncertain quantity, and let's say on average it is 200. Okay, so let's call it average demand. Okay, and this is an uncertain demand. We'll use a different color code for that. Okay, I don't know what I used in the previous example. I need to be consistent. Now order quantity, so how many units you're going to order. Okay, and let's say we're going to order 200 units, the average demand, and that's our decision variable. Okay, so our deterministic model now is, okay, what is the demand? Demand is that. Okay, what is sales? Sales is, okay, the smaller of these two. If the demand is 200 and you only ordered 150, so you can only sell 150. And if you ordered 200, if the demand was only 150, then you will only sell 150. So the smaller of the two is your sales. Now revenue is sales times unit price. Okay. The cost is, okay, now cost is not from sales but from how many units we have ordered. We ordered 200, so 200 times 750. Okay. And will there be any refund? Well, that's going to depend upon order quantity and sales. So the order quantity minus sales will give us how many units we have to send for refund. Now this cannot be negative because the sales is a minimum of these two. So sales can never be greater than order quantity. So this will, you don't have to use a if statement here. This is going to be non-negative. So times $2.50 will give us the refund, and then the profit is then revenue minus cost plus any refund that we get back. And that's our output of interest. So this is our basic model, right? So now let's say we want to simulate this. Okay, so we go to this column, this sheet. Okay, so now all of this is same as before, but here instead of demand being assumed as 200. So call it average demand. Okay. So this is going to be not an input cell, but an uncertain quantity. Okay. Now to simulate the average demand from this demand distribution. So here we are going to assume that the demand is going to be one of these numbers with the discrete probability distribution. So it cannot be anything other than these 5 numbers, and for each of these numbers this is the corresponding probability. Okay. So now we set up the cumulative probability for X lookup. Okay. For X lookup, you don't have to use lower limit. You can have a regular cumulative probability because you can use the match mode of equal to 1. So I'm going to show you now how to use match mode of -1, right? So if you want match mode of -1, then you have to start with the lower limit of each cumulative probability, and in which case you have to start with 0 and then the previous probability plus the previous cumulative probability. So then this will go up to the lower limit of the last row. So anything greater than or equal to 0.95 will be 300. Okay. So when you use it in this fashion, then you can do an X lookup, right? Rand, that's our probability. Okay. Now that's the lookup range. Okay. And this is the output array, and then you have to skip a comma. So you need 2 commas, then you get the match. So we want -1 as the match. Okay. So then, okay, so let's try. Okay, so that we got a 300. So we want to make sure that you do get 300. Okay. And 300 has a very small probability, so it took a while for us to test whether 300 is coming up as a possible demand. Okay. So now we use that as our demand. So now we have the simulation model. All right. Now we need replications. So you can say replications using data table. So the number of replications will be, okay, let's say we want 1000 replications. Okay, highlight, and then you go to fill series, you say 1000. Okay, and then the output is the profit, and then you run the data table. Okay, so go to data, order of analysis table. Now the replication numbers are column, so it's a column input cell, and This is not part of the model. It's only used as a convenience to force replications. So we select some empty cell, click OK. Okay, remember we selected calculation options to be automatic except for data tables. So if you do calculate sheet, so it's going to calculate the replications, and then we can set up some statistics from these replications. So minimum profit, right? It's somewhat easier if you give a name for these replications. So highlight the replications and then define name and we'll call it reps. Okay. So and then average, and then you say reps. Okay. And then standard deviation dot s reps. Okay. Maximum profit of reps. Okay. Then usually you will be interested in the percentile. So what is the 5th percentile of profit? What is the 95th percentile? The 1st percentile, 99th percentile, and things like that. So in Excel we have percentile.exe and you give the array reps, okay, and then the percentile we want. So if you want 5% percentile, you have to specify 0.05, then percentile of reps, say 0.95. Okay. These percentiles are very important output measures that are useful. Okay, so we'll go ahead and format these to currency. So now we did this. It's slightly more involved example than price elasticity of demand. And now let's next let's look at how to do this in at risk.